Welcome viewers, in this video we will see the details about substitution theorem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. Substitution theorem, one of the theorem available in the circuit theory. First we will see the statement. Any branch of network can be replaced by a different branch as long as its potential and current remain unchanged. So in any network we can change the branch from one branch to another branch, but the potential and current should be remain unchanged. Without affecting potential and current, we can replace a different branch. When the original branch is passive, either a voltage source or current source is generally used for substituted branch. So it should be passive. The original branch is passive, then either voltage source or current source can be substituted. This principle is sometimes useful in analyzing the behavior of the network. So the application is we can analyze the behavior of the network. Since the solution must be known before substitution can be done, this principle is useless in finding numerical solutions. So only we can analyze the network. Numerical solutions not available. Right? So since the solution must be known before the substitution, so we should know what is the voltage and current. Thereafter only we are replacing, we are substituting. So that is given. So the numerical problems we cannot see that. We can analyze the network. So the network can be replaced by different branch without affecting current and voltage is nothing but a substitution theorem. Now we will see the example. So consider the network shown below. We will see the network is available. The 48 voltage is there, right? There are 1, 2, 3, 4 resistors available. 4 ohm, 2 ohm, 8 ohm and 6 ohm. The 6 ohm is taken as a load terminal, or the terminal is marked as PQ, P and Q, right? The 48 voltage is available. The 6 ampere is flowing through this 4 ohm resistor. Thereafter in the second loop, this is maybe the first loop, second loop, 3 ampere is flowing in this second loop. So 3 ampere is flowing through the 6 ohm resistor. Now we are going to replace the branch, so that we are going to substitute here between the terminal P and Q. The 6 ohm available and 3 ampere is flowing. So what is the current through this branch? IPQ, current flowing through PQ is 3 ampere. What is the voltage? VPQ is nothing but V equal to I into R. I is 3 ampere, R is 6 ohm. So 6 into 3, 18 voltage, right? So we are going to substitute this branch PQ with a different voltage source or current source. For that we need to maintain the current flowing through PQ is 3 ampere. We need to maintain the 3 ampere. Similarly, the potential across P and Q, VPQ is nothing but that is the voltage across 6 ohm resistor is 6 into 3, 18 voltage, right? So now we'll see what are the possibilities to replace. We substitute this terminal PQ with the different branches with the value of current equal to 3 ampere and voltage equal to 18 voltage, right? Now we'll see the all the possibilities. What are the possibilities are available? So the branch PQ has current of 3 ampere and voltage 18 voltage. Without changing these two values, we can replace the branch PQ by any one of the branches shown below. So there are 4 possibilities available. This PQ, the terminal PQ, we are going to change. That is 6 ohm, 3 ampere. This is the original. Already 6 ohm is available with 3 ampere is flowing. So current is 3 ampere, voltage is 3 into 6, 18 voltage. So directly we can replace with 18 voltage source, right? So the 18 voltage source, so see that the current also 3 ampere. And another possibility is we can change with 12 voltage in series with one more resistor, 2 ohm. The 3 ampere is flowing. So what will happen? This 12 voltage is available. Already current is maintained 3 ampere. the 3 into 2, the voltage drop across this resistor is 3 into 2, 6. So 6 plus 2, 12, 18 voltage. So we can maintain the 18 voltage. Here 18 voltage source is directly connected. Here 12 voltage source is connected, but we have one 2 ohm resistor available. The voltage drop across 2 ohm resistor is 2 into 3, 6. So 6 plus 12, totally 18 voltage will be there. And another possibility is the voltage source is connected in reverse. This terminal is negative and this terminal is positive. Here plus minus minus plus. So we will get the negative voltage here. That is 9 voltage. In series with we have 9 ohm resistor available. The current is maintained as 3 ampere. So what will happen? Here minus 9 voltage is available. This will be plus 12 voltage. The terminals are reversed. So we have minus 9 voltage. What is the voltage drop across this 9 ohm? 9 into 3, 18. 9 into 3, 27 voltage. Plus 27 voltage will be there. 27 minus 9. From 27 we need to subtract minus 9. So that we will get the 18 voltage. The 18 voltage will be maintained in this branch PQ. Right? So in the first possibility, 18 voltage source is directly connected. In second possibility, 12 voltage source connected in series with the 2 ohm resistor. So 2 into 3, 6 voltage plus 12, 18 voltage is maintained. In the third possibility, 9 voltage source is connected in reverse order. So that we got minus 9 voltage. But we have one 9 ohm resistor is available. So 9 into 3, 27. 27 minus 9 we will get 18 voltage. So in all the cases we are getting 18 voltage, right? So the original branch PQ with 6 ohm resistor and 3 ampere, that is a voltage drop of 18 voltage is replaced with these 3 different possibilities. Now we will go for the further description. The substitution theorem can be stated in the following simplest way. Another one more way of statement is available. A branch of a network carrying a current I can be replaced by a voltage of value I into Z. V equal to I into R. I into Z, impedance, current into impedance. Where Z is its branch impedance without affecting the other parts of the network. Right? So the branch of network carrying current I. In that we are going to replace with a voltage. Replace by a voltage. That voltage value is I into Z. The I is already available. Current is flowing. What is current is flowing? Into Z is nothing but impedance of that network. So that if we replace the voltage with I into Z, that will not affect the other part of the network. So this is the another way of the statement. Now we'll see the compensation theorem. So that is the corollary of the substitution theorem. The compensation theorem, it is the corollary of substitution theorem. Right? Both are interrelated. So we'll see the statement. When the resistance R or impedance, in case of AC network, impedance of a branch carrying current is increased to R plus dr. Dr is the change in resistance. Otherwise, Z plus dz. Dz is change in impedance. The changes takes place can be found by connecting series voltage I into dr or I into dz, opposing the current flowing in the branch Z plus ds. Right? So one network is available with resistor R or impedance. In that we can increase, in that the current is increased to, the carrying current is increased by changing the resistor R plus dr or Z plus dr. The changes takes place can be found by connecting series voltage source. When the resistor is increased, we have to connect the series voltage. That voltage is I into dr or I into dz, so that we can compensate. While increasing the resistor or impedance, the corresponding series voltage should be added. Right? That voltage is nothing but I into dr, change in resistance, or I into dz, change in impedance, opposing the current flowing in the branch of impedance Z plus dz. This voltage is called a compensated voltage. That is given by I into dr or I into dz. So it is very simple. In previous substitution theorem, the branch is replaced by all other combination. Voltage source or current source is replaced by maintaining the current and voltage. Here we are adding the resistor so that the compensated voltage is connected. That is calculated as I into dr, current into change in resistance. This is the original current flowing in the circuit. After increase the resistor, that is multiply with I, that is nothing but Vc. So while increasing the resistor or impedance, we need to connect the compensated voltage, that is calculated as I into dr or I into dz. Vc is a dependent source. The polarity of Vc must be to oppose the original current. The polarity must be opposing. You have to connect in reverse order, right? So this is corollary of the substitution theorem. We will see the further important points. The compensation theorem is used to study the changes in the voltage and current of a circuit when the impedance of any one of the branch is changed, right? So the compensation theorem mainly used for changes in voltage while changing the impedance. So that is called R plus RR. When the resistor is increased from R to dr, what is the changes in the voltage? How the voltage and current will affect? The change in current and voltage in each branch of circuit is the current or voltage that would be produced by the opposing voltage. It's called a opposing voltage. That's why we are connecting the compensated voltage in opposing, in a reverse order, opposing order, right? So the thing is, while increasing resistor or impedance, there is a change in voltage or current, that is nothing but opposing voltage. While changing the resistor, one opposing voltage is created. So that is called a compensated voltage. So that we should connect in a reverse order. So in this video we discuss about the substitution theorem and corollary of substitution theorem, compensation theorem. How to change the, what will happen if the resistor is increased, that is compensated by compensation voltage. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.